Okay, so now that we're starting up AVR Studio for the first time here, we're going to create a new project. I'm going to definitely use the AVR GCC because we don't want to have to write an assembler. Project name, test debug. And make sure we've got the create folder and create initial file check. Doesn't really matter, but could help. Okay, now normally you'd probably go to the simulator and then select the chip, but in this case we've got a JTAG Mark II, so we're going to use that. USB 1289 port auto. We can actually specify USB if we wanted to, but it should be able to find it no problem. Oop. Where are we? Good. Finish. Alright. Now we can load up the appropriate source file. Okay, when you first connect, you might want to update the firmware of the JTAG. If so, just let it do that. It should be able to complete pretty quickly. And then, good, we should have it falling apart on us. Let's try that again. Well, at least it saved our old project there, so we're going to load that up again. Now let's try connecting to the AVR device again by clicking on the AVR button over here. And let's see what happens. Good. Managed to get it this time. Now the first thing you'll notice... Oh, hello you. Don't. Okay, the first thing we'll notice is that on the main here, it's set up to ISP mode by default. Well, we've actually connected to JTAG, so we want to actually make sure we've got that selected. You can read the device signature if you've got a device attached like we do right now, the USB right there, to make sure that yes, indeed, we have selected the device properly. And you can also see the fuse bits will be selected as they should be. Good, and you should be able to see, yep, everything's set there properly. And if you go to lock bits, same thing, it'll actually load what is specified in the device right now. You can do your programming here as well if you want to update an individual file, but for the most part you'll use the IDEs instead. Okay, so I've just altered the project so that we can have some additional features here, just simple RTOS with some things. But we're going to have to change some of the configuration options quickly. For one thing, we need to set the appropriate CPU rate to 6 or 8 million. Good, and the other thing we've got to do, because we're using the RTOS, is change the linker such that there is the no start files option. Ugh. There we go. Okay, now I'm going to open up the very simple file we're using for our main project right now and throw in a breakpoint or two. Let's make it 2. One there, and why not one over here? Excellent. And we'll be able to debug this in a second here. First we got to make sure it's built. You don't see many mistakes. Looks like we managed. Message, eh? It's alright, good. Then we can start debugging, and it should automatically go onto the device itself. Excellent. Okay, this demo is going to be a little bit cumbersome with just one person doing it, but we can see we've got that project that you might have just seen from the screencast, and we are right now in the main. And if we look down on the actual AT90, down there we can see that just the power light's on. It's kind of hard to see, right? Try to pick it up. Okay. Alright, just the power light is on. Now, back on the screen here, if we keep on running forward, this is the run button. We get to the first breakpoint, nothing really happens there, so we'll go to the next part here. Getting to the second breakpoint, and you notice that after this breakpoint, I should put a breakpoint on the one below. Breakpoints, not bookmark. Then we should be able to see, there, now we've gone to that next part. If we look down here back at our device, we see that we now have an additional LED lid as well, because that's where it currently is in the system. So it's actually running through and braking and stopping the system at this point.